When we're talking about the sunspots, another interesting fact is that the sunspots come and go over a cycle of 11 years, approximately 11 years. We can see here at the bottom the sunspot cycle from 1880 to close to the present, the ups and downs, or the number of these sunspots that we can count on the surface of the sun, and the peaks of this plot, or the minimum of the plot, approximately 11 years apart. On the top, we can actually see the disk of the sun, again in ultraviolet, so not in the visible. So here the sunspots appear with the brighter colors. And we can see going from the quiet period, for example, here in 1997, where we were close to the minimum of the sunspot cycle. And then when we come to the maximum, around about 2001, 2002. You can see the different features on the sun because of the changes in the sunspot cycle. So sunspots appear, they increase and decrease and reach another peak every 11 years, what we call the sunspot cycle. Another interesting thing about the sunspots is that they don't appear randomly on the disk of the sun. If we look at this plot here again from about 1870 onwards, at the bottom we can see the number that's actually telling us the number or the relative number of sunspots going up and down 11 years. But on the top plot, what we call the butterfly diagram, it looks like butterflies, we can see the latitude of where these sunspots occur. And you can see, so we have the equator of the sun in the middle, going up to the North Pole and the South Pole on the y-axis, and the same time axis below. And what we see is that at the beginning of the solar cycle, the sunspots always appear far away from the equator, around about 35 degrees north and south. And with time, they propagate towards the equator. We can see, for example, here, the propagation going from high latitudes to low latitudes. And at the beginning of the next solar cycle, they jump again to around about 35 degrees and then start to again propagate in. So this way, we can also know when we've ended one solar cycle and started the next by looking at where the sunspots are occurring. If they are close to the equator, then that's the end of the one. And as soon as they start to appear at 35 degrees north and south, then we know we're in a new solar cycle. It's also interesting that we don't have many sunspots at the equator. At the equator it is fairly clean here, and this is still something not really understood. But again, the differences in the velocity of the rotation of the sun are felt mostly in the tropical regions of the sun, and therefore this is where we think we see most of these sunspots. In the polar regions, we don't see any sunspots, and again, very few along the equator. Now, these sunspots, it's nice to observe them and to see the variability. And again, we can see here from 1975 at the bottom the number of sunspots on the sun's surface. But this is also directly related to the amount of energy that the sun is giving or outputting and how much is arriving at the Earth. And this we call the total solar irradiance, TSI. We measure this in watts per square meter. So this is the amount of energy, watts per square meter, outside the atmosphere. So if we're on a satellite, for example, and these data here in the colored dots are taken from satellites outside of our atmosphere, so there's no absorption of the radiation. The different colors of different satellites, different sensors. Again, satellites only last for maybe 5-10 years, so we have to replace them. But what we see is that there's some correlation between the number of sunspots and the activity of the sun and how much energy is given off from the sun and arrives at the Earth. The average value for this, 1,362, is what we call the solar constant. And we represent this by S0. S0 is the solar constant. But as you can see from this plot, the solar constant is not really constant. It is fairly constant because if you talk about the changes we're seeing here over the solar cycle, we're going from maybe 1,360 to 1,364. So we're talking a much less than 1%, the variability of the solar radiation. But still, the solar constant is not constant. And in fact, we see the peak of the solar cycle, where we have most of the sunspots, we actually have lots of variability these dots are spread over quite a large range in the amount of energy coming from the sun, compared with the minimum of the solar cycle, where we have very few sunspots, where the sunlight is very stable and the energy is very stable. So when we don't have any sunspots, we have low energy coming out of the sun, or less energy, and it's very stable. When we have the maximum storms and sunspots on the sun, we have lots of variability and the maximum amount of radiation reaching the Earth. And as I mentioned, the difference between the minimum and the maximum here is only about 0.1% in the amount of radiation we're getting. And so we can look even over a longer period of time at the sunspot cycle. As I mentioned, Galileo was the first one. 1650s, the red dots you can see here from the beginning, the 1600s, 1650s, was when Galileo was looking with his telescope at the sun and counting every day, every month, the sunspots on the sun. And in more modern times, we have better instrumentation. But we also see, instead of just the 11-year cycle, we also have longer-term cycles and ups and downs in the solar activity. We have an 80 to 100-year cycle, which we can see in this plot. We also see a 180-year solar cycle. And it turns out that all of these variabilities, the 11-year, the 80 to 100, the 180, we can find in the climate system, whether it's in sediments, in the oceans, in lakes, in tree rings, in river flow. We find often these periodicities also occur in the climate system. And so many people think that the variability of the sun is obviously strongly linked to the climate of the Earth. We'll talk about this a little bit more throughout the course. One interesting thing here is that there was a period which is called the Maunder minimum. We can see it here from about 1645 to 1715, where we saw no sunspots on the sun. Very strange. The sun didn't turn off. The sun was still active, but we saw very few, if any, sunspots over approximately a 50-year period, a little bit longer. And this is a puzzle, what happened during this Maunder minimum. And people think that this is also related to the climate, and we'll talk about that in the next unit.